Hello guys. So you may be wondering, why is there nothing on the screen? Well, this is a special kind of video, and instead of your regular I play a game, you watch type of game, type of video, um this is like a it's a honestly chemistry type video, if you know what I mean. So yeah. So the thing that we're going to be talking about is orbitals, right? So a lot of people may be like, what on earth is what is an orbital? So the most basic understanding of it, what I think is the most basic understanding of it, is a 3D version of an atom. That's very simple. Like, it's very simple. An orbital is basically a visual representation of a 3D atom. Yeah. So the thing is, an orbital isn't really the whole atom. It's just more about the electrons in the atom. So what I mean is that there's about 4 different types of orbitals. There's S, P, D, and F, right? And they all have their own respective areas on the periodic table. And so orbitals, what they're more commonly, or what they actually are, is they are areas of the atom where there's a high probability of finding an electron. There's also one more thing to note, is that electrons do not spin. So when people are taught chemistry and stuff, they're taught that like there's the nucleus, there's the electrons spinning around it, all that stuff. Yeah, that like you could do a lot of stuff with that. With just that, you can understand a lot of it. But the thing is, that's 2D, and like so what we're taught is 2D and stuff, and orbitals are like 3D. But the thing is that um electrons don't spin. So if I got an image of like an orbital, it would uh, if I got an image of a true orbital, like a fuzzy one, like the S orbital, then it will be a fuzzy little like circular cloud. It won't be like so. A lot of you are probably confused at this point. You're like, what on earth is going on? Why? What? So, um, to try and help you a bit more, I am going to show you some images of the orbitals, and try and make you understand them. So, um, so we have s orbitals, right? Um, they are the simplest forms of orbitals. They're the most simplest. And as you can see, there is an s orbital on the screen, and the thing is that s orbitals, they are also the lowest energy. They have the lowest energy state. Like they're the lowest energy state. So what I mean is that like it's kind of like gravitational potential energy. When you talk about that, the more higher, the more it has, and the lower it has. So basically, it's kind of like that. So you could think of the electrons as like balls, for example, and let's say you pick up a ball and you like lift it up. The ball now has more uh, gravitational potential energy, right? That's like the same with the electrons. The further away it is from the nucleus, the more gravitational potential energy it has. Well, not gravitational potential energy, but the more energy it has. So like s orbitals, because they are quite close, then the s orbitals are normally the lowest forms of energy. Oh, look, yeah, and so I've just been calling them s orbitals and all that. They don't. It's not just like SPDF. It has these numbers, right, for like the atoms and stuff. So the simplest first form of s orbitals is 1s, right? So I'm just gonna pop up an image of the the electronic configurations, I think, of some atoms from like hydrogen to magnesium, if I'm correct. Yep, so you can go ahead and look at that. That should be enough time to look at that. So so if you looked closely, you probably weren't able to, you'd actually see um you'd see like what's it called? These yeah, alright. You see like 1s, 2s, 2p, all those, right? So what that means is that the number that you see, so 1s, right? The number that you see is the the shell number. So you know how there's like the first shell with 2 electrons and all that. So the number represents the shell number. So 1s would equal the first shell and stuff. And then like s just represents what orbital is. And so if you saw, there were these arrows. What they represent is the like electrons and the spin of them. They don't really spin. And so the first one is normally up, and then the second one is normally down. And if you looked at the other ones, so like if you went further down to like when you go to like so after helium, I'm just gonna pop it up again. So if you looked at helium, for example, it has 1s, and then helium has 1s, right? And if you see, there's 1 and 2, right? If you were doing the electronic configuration of helium, that would be 1s2. So 1s, then a little 2 at the top. Then when you get to lithium, right, that has 1s and 2s, if you can see. So what happens is that so 2s is just the second shell, right? Because that makes sense. Lithium has 2 shells. So we have 1s, which is the first shell, and 2s, which is the second. And there's this thing where every orbital has a maximum of 2 electrons. So 1s is 2, 2s is 2, stuff like that. And when when you look at like lithium, it has the 1s is filled up, right? But then the 2s only has 1, right? Then when you look at beryllium, it has the same thing, but now it has 2 electrons in 2s, right? But then when you look at boron, it's a bit of a different story. So boron, it has 1s, 2s, and 2p, right? And as you could see, there's 3 2p's. So 1s and 2s, they're just spheres, right? They don't have any, like, if you spin it, if you like rotate it, anything, it just looks the same no matter what. But p orbitals have a specific shape. They have the shape of a like dumbbell, or you could also say is an infinity sign, kinda. But because of this, they can be rotated in the different axes. So you have X, Y, and Z, right? And when and so with with boron, right? The 1s is full, 2s is full. When you get the 2p, what it does is it goes to the first. It can go in. It could go to 2px first, 2py, 2pz. It could go in any of those first, but it will go into one of those, and then it will just But then when you get to carbon, I think it at first you'd be like, okay, so if it goes like 1 and then it adds a second one, should that be the same? No. If you look at carbon, it's a bit different. So as you can see, it has 1 in the first one and 1 in the second, instead of having like 2 in the first. You're like, huh, that doesn't make any sense. So what I think is that it's a lower energy, it takes up less energy to go into the next p orbital than to go into the same orbital. But then when you get to what was it again? Nitrogen. Nitrogen, it has one electron in each p orbital. So after that's done, then it'll just repeat again. It'll just put an electron in the first one, the second one, and then the third one, and then it's full. So neon. But then after neon, it gets to I forgot what it was, like sodium, if I'm correct. It goes to sodium, and then it goes to magnesium and all the others. And so if you want to know what boron, I'm just gonna do boron for example. If you want to know what like boron and stuff like that looks like, then here you go. Yep. So I'm going to stop there. That may be good enough for you, but if it isn't, well, I could just make another video. So, yeah. So, bye.